So chapter 4 introduces us to solution chemistry and then 3 important kinds of reactions that occur in particularly aqueous solution. So we started the chapter just reminding us of some D and some S words to talk about the difference between, for example, sugar dissolving in water versus table salt like sodium chloride dissociating in water or breaking apart into ions, and then introducing the concepts of strong and weak electrolyte solutions having to do with how many ions do you make in solution. Once we understand how solutions are prepared and how we think about the ions or molecules in solution, then we started thinking about chemistry that can happen. So the 3 kinds of chemistry that are part of this chapter, the first is precipitation chemistry, and that has to do with taking 2 solutions of ions and mixing them together and then asking, well, if we have some new pairing options, do we form something that's soluble or insoluble? And so using table 4.1 is going to be really helpful for that, and that table will be provided for you. The second skill in the chapter is thinking about acid-base chemistry. And so for this situation, table 4.2 is something that you need to commit to memory. And the reason is that it's important that when you look at a molecule, you look at an acid or a base, you're able to recognize fairly quickly whether it's a strong acid or a strong base. And so use table 4.2 to help study, but that is not one that will be provided for you. The third concept that we talk about in this chapter is oxidation reduction chemistry, often called redox chemistry. And it's chemistry that involves kind of the changing or swapping of electrons between species. So we'll talk about concepts with that have to do with assigning oxidation numbers and so forth. A lot of these problems kind of build on previous skills. I cannot highlight enough the importance of learning to name compounds in chapter 2. As you can see with most of the sample problems that we did, as well as most of the homework problems, you are not given a chemical formula, you are given a name. So you need to be able to convert that chemical name into a chemical formula before you can even think about balancing a chemical equation or doing something like a stoichiometry problem with that. So all of this chemistry is starting to be layered on one another, which is why it's important to know how to name things, important to be able to balance chemical equations, be able to do stoichiometry, be able to think about limiting reactants, because now all of those concepts from chapters 2 and 3 are built upon in chapter 4 with those 3 kinds of reactions. So we're not really doing any new sorts of chemistry, we're just applying that chemistry to new contexts. So this is how most of general chemistry is going to kind of progress, is that all of these concepts sort of build on one another.